Hello. Today the topic is conservation of momentum. We have three cases. Okay. So we're gonna have M1 that's coming in. Okay. So actually, I'm changing my mind. So M1 is gonna look like this. It's gonna be a bullet that's flying in, and M2 is going to be sitting there. Okay, so let's say M1 is equal to 10 to the -3 kilogram. So it's a bullet, 子弹. And M2, let's say, is equal to 1 kilogram. All right, and M2 was sitting at rest right now. So V2 is equal to 0. And V1 is equal to, it's a fast speed. So V1 is equal to, say, 10 to the 3 meter per second. So that's very fast, okay? I don't know if I can find a bullet that fast. Okay, so I'm going to assume that there are three different situations. So one is that this bullet comes back, and so V1 prime is equal to, say, 100 meter per second. Okay? You know what? I'm going to change my mind. I'm going to say this one actually come back and it's equal to 10 to the 3 going this way. Okay? The bullets come back and traveling back this way after the collision. So V1 prime is coming back this way. And then the other case is the V1 gets stuck in there, right? So the other case is not V1, but M1, right? So the bullet gets stuck and just kind of stick in there, right? Stuck. The bullet stuck. All right? So that's the second case. So this is case 1, case 2. In case 3, the bullet went through, okay? The bullet went through. So I'm running out of space. I'm changing color here. So the third case, the bullet went through and just kind of come off here. I'm just going to come out here. So the V1 prime is equal to, say, 100 meter per second. All right, so those are the three cases. I want to discuss what would happen. All right, so let's erase it and we'll continue. Okay, so let's redraw this a little bit. And we have this. So for the case 1, this guy bounced back, right? This guy goes and come back, right? So this guy come back and V1 prime is equal to 10 to the 3 going to the left. But V1 is going this way, right? V1 is equal to 10 to the 3 going to the right, okay? And this, so now the question is, how do we find V2 prime, okay? So let's do that. So M1 V1 plus M2 V2 equal to M1 V1 prime plus M2 V2 prime, right? So this one is equal to 10 to the -3 kilogram times V1, which is 10 to the 3, and plus V2 is equal to 0. So that's plus 0. And M1 V1 prime is negative, right? So it'll be 10 to the -3 and times -10 to the 3, okay? And then plus M2 V2 prime, okay? And this is equal to 1. All right, so then we move this to that side, so that becomes 2, right? 2 is equal to V2 prime. So we know V2 prime will be moving to the right and is equal to 2 meter per second. Okay, so that's case 1. This is case 1. Right, so 2 meter per second. Let's remember that. All right, case 2, let's do it. All right, so case 2 is I have the bullet and it got stuck, right? So bullet got stuck. Okay, so let's do that. So M1 V1 plus M2 V2 and stuck, so we can use M1 plus M2 and then V stuck, right? So this says 10 to the -3 times 10 to the 3 plus, this is 0 because V2 is originally 0, and this is equal to 10 to the negative 3 plus 1, and then v prime. So this is almost equal to 1, right? Almost equal to 1, you can see. And this is 1, right? So then v prime is very close to 1, right? So this is 1, and this is almost 1. So v1, v prime must be equal to about 1 meter per second. Remember the case 1. So this is case 2, right? Case 2, okay? So case 1, we have v2 prime equal to about 2 meter per second, right? Okay, let's check case 3 now. Case 3, what would happen? So we say this bullet will come out, and now this velocity is equal to v1 prime equal to 100 meter per second, right? Okay, let's change in color a little bit. All right, so we have m1 v1 plus m2 v2 equal to m1 v1 prime plus m2 v2 prime. Okay, let's take a look. So we have this one here is 10 to the negative 3, 10 to the 3 plus m2 is 1, right? And that's 0, that one's 0, and equal to m1, which is equal to 10 to the negative 3. And it's continued positive, right? But it's 10 to the 2, and then plus m2 is 1 times v2 prime, okay? So then this is 1, so changing color again. So let's make that one this color. So this is 1, that's 0, and this one here is 10 to the negative 1, right? Okay, so then you minus that, so it's going to be 0.9. It's equal to v2 prime, okay? All right, so it's a little smaller than that one. So you can see this one here is the case 3, so it has the smallest velocity, right? All right, so then this is case 3 here. Okay, all right, so let's analyze this as a little bit, right? So for the 3 cases, you can see the 2 and 3, 2 and 3. Because if you analyze it, because the bullet, right? So basically took away, right? Took away some momentum in x direction, right? For case 3, right? So he took away some momentum, right? Some, then took away more momentum in x direction for case 3 than case 2. Okay, so that's why the v2 prime, which is equal to in the case 2 is equal to 1, right? Meter per second. But in the case 3, v2 prime is equal to 0.9. Because this bullet, it was coming this way with 10 to the 3, and after the mass, it went with 10 to the 2. So it took away 10 to the 2 meter per second momentum in the same direction. So you were left with less momentum that can be used by this M2 here, okay? Compared to if you would have the bullet that gets stuck in there, now you know this velocity is not going to be 10 to the 2, it's going to be a lot less. So in this case, bullet only has less momentum than the 10 to the square, okay? So bullet took away more momentum in x direction for case 3 compared to case 2, right? And in the case 1, bullet, right? Bullet rebounded, went to the negative x direction, right? To the negative x direction, rebounded to left for case 1, right? So that's why v2 prime is larger than, right? For the case 1, this is case 1, right? This is for case 1. It's larger than v2 prime. This is for case 3, right? This is for case 3. Is larger than v2 prime for the case 2, okay? So that is your final conclusion if you would analyze this problem. And why this is happening, it's because the bullet took away the more momentum in the case 2. And it didn't really took away any momentum. It went the other way. So it actually gave more momentum to the M2 for the case 1. And for the case 3, it got stuck. So it has the smallest momentum left for the bullet. So that's why the M2 will have a little bit more momentum afterwards than the case 2 situation, right? Okay, all right. So that's what we have today. All right, hopefully that all helping you to understand the momentum conservation problem. Bye.